In this video, we're going to look at the Newton's third law, and it's a simply stated law. And let's only read the portion of the law that's underscored with the red line. It says, for every action, there is an equal and opposite reaction. That's how most people know Newton's third law. So I put a few little words in there. So for every action, or for every force, there's an equal in magnitude and opposite in direction force pushing back. So as an example, we have a person here pushing against a wall. So let's put that down. So the person is pushing against a wall, and let me do it like this. There it is. So this is the force of the push. And of course, according to Newton's third law, that means that the wall is pushing back against the person, and that's indeed true. So there's a reactionary force. So if the person pushes with a force of 30 pounds, the wall will be pushing back with a force of 30 pounds. So there's an equal and opposite force pushing back, so that's the force of the reaction to the push of the person. And let me put a little line on top of the force here, because after all, it's a vector quantity. So if the person pushes now with a force of 40 pounds, the wall pushes back with a force of 40 pounds. 50 pounds, the wall pushes back. So it's always equal and opposite, equal in magnitude, opposite in direction. Now you may say, well, wait a minute, if the force of the wall is pushing back on the person, shouldn't that be pushing the person back? And it turns out that it would. For example, if the person was standing on roller skates and you push against the wall, you will push yourself back. By pushing against the wall pushes back and you'll go backwards. But there's something else going on. There's a friction force between the feet and the ground. And so because the wall is pushing this way, that means that that force would then transfer through the body to the feet, and the feet would be pushing against the ground in this direction. So that's force of the feet pushing against the ground. And of course, that force would have to be equal to this force. And of course, if the person is firmly anchored on the ground and has good shoes on with good soles that don't slip, then of course the ground would be pushing back with a reactionary force, F reaction, which would be equal and opposite to this force of the feet pushing against the ground. Reaction, that's right. There's one more, of course. Then we have the weight of the person pushing down on the ground. So we have the force due to the weight. So force due to gravity, so F sub g as I call it, which is equal to the mass of the person times acceleration of gravity. And again, there is a reactionary force, the ground pushing back against the person, and that would be F reaction. So you can see, in a simple case where a person pushes against the wall, we have three examples, Newton's third law. The person pushes the wall pushes back. The feet push against the ground pushes back. The weight of the person pushes against the ground this way, and the ground pushes back. And because they're all opposite and equal, opposite in direction, equal in magnitude, of course, then in this case, there's no net force acting on the person, and the person will remain there according to Newton's second law. If F net equals 0, no acceleration, person will stay right there in place. Now, of course, if you put roller skates, roller blades on the person, and the person pushes the wall, the person would simply then start rolling back and experience an acceleration, because at that point, there will be a net force, because there will not be anything to cancel out the reactionary force of the wall, nothing down here, and the person will simply slide backwards. So here's a good example of how to apply Newton's third law.